Okay, I have already sent to you the link, the YouTube link of today class in the WhatsApp group. Okay, let's we start the class. Uh, sorry about the noise from the in the background of my my Zoom. There is an construct there is a construction activity in uh, my my house. Okay, let's we talk about meeting 13. Meeting 13 will be discussed about partial derivative, total differential, and chain rule in multivariable function. I will review a moment about meeting 12. We have already mentioned in the uh, previous week, but I will uh, review for you. Okay, this is meeting 12 in the last week. We talk about quadric surface. Quadric surface is the surface comes from this formulas. Uh, the formulas, their formulas consist x square, z square, or combination of xy, zy, xz, and so on. This is a general form of quadric surface. And there are several kinds of quadric surface. Uh, in example, cylinder, ellipsoid, sphere, paraboloid, and cone. We will talk these kinds of quadric surface one by one. Number one, we will talk about a cylinder. A cylinder is a surface that is generated by, sorry, wait a moment. The A cylinder is a surface that is generated by moving a straight line along a given planar curve while holding the line parallel to a given fixed line. So there is a curve, we call it generating curves, and we move the curve along a straight line. In this case, in this example or in this illustration, we have generating curve as a red color curve, and we move these generating curves along x-axis, along x-axis. So the surface from that kind of uh, generating curves is called a cylinder. There are several types of cylinder based on the generating curves. For example, a circular cylinder, it means that the generating curves of the cylinder is a circle. Parabolical cylinder means that the generating curves of the cylinder is parabolic. and the elliptical cylinder means that the generating curve of the cylinder is elliptic. Here we find some illustration about a circular cylinder in the uh, upper right. We find that a circular cylinder which has generating curve is a circle in the xy plane, and the line is z axis. The line and the circle move along a z axis. Z axis as axis, uh, or we call it sumbu. Yeah, sumbu. In the left, we find that the circle, the generating curve is a circle in a YZ surface and move along x-axis. You can look at the formulas of the circular cylinder in the first illustration is x square plus y square is equal to a square. There is no z z variable here. There is no z. In the left, you can look at that the formulas of this surface is y square plus z square is equal to b square. So you can look at there is no x variable here. I hope you can draw the circular cylinder based on this formula. X square plus z square is equal to c square. I will help you to draw uh, in this in this sorry in this for these formulas we that we have the circle in the x z surface, and the and this curve uh, move along y axis. So this is the circular cylinder for this formula. Okay, let's we continue with the parabolical cylinder. As I told you before, this parabolical cylinder means that the parabolic move along a line, a straight line. For example, y is equal to x square. Uh, it, it means that we have this parabolical cylinder. Y is equal to x square and move along a z axis. So we have this kind of cylinder, and also z is equal to x square. It means that the curve is z is equal to x square and move along y square. Based on uh, those two previous examples, we hope you can do or you can draw by yourself this cylinder based on these formulas. X is equal to y square, z is equal to y square, and so on. I will help you to draw in these formulas, and the rest of the formulas should be drawn by yourself. X is equal to y square. It means that in two dimension we have x and this is y, and uh, x is equal to y square means that the parabolical like here, the parabola like here, yeah, to the x axis. So we should draw the the parabolical in the three dimension. This is two dimension, and this is three dimension x, y, z, and we have that the parabola goes like here, and then move this curve along z square. Move this curve along along z square. So here the cylinder of this formula. Okay, and sorry, I should I do 40? Okay, clear. Okay, let's we continue with the elliptical cylinder. Elliptical cylinder means that we have a cylinder as the generating curve and move this ellipse along uh, a straight line. In this case, along the axis. In this second example, we have this elliptics, this ellipse, and move along y square, y sorry, y axis. So this is the draw of these formulas, the picture of this equation. Okay, let's and we I hope that you can draw by yourself this the picture of this equation. Okay, let's we goes to paraboloid. The paraboloid means that uh, surface uh, have uh, a paraboloid shape, a paraboloid shape. So we call it a paraboloid. In bahasa, we can say that this is mangkuk, seperti mangkuk, seperti wadah, mangkuk. Okay, let's we look at the equation for the paraboloid. We have that there are two variables have power of 2, and one variable have power of 1. And uh, the what we call uh, in bahasa we say it as penampang. We have penampang or what we call in English uh, a front surface, or I I I forgot the penampang of the paraboloid determine the name of paraboloid. For example, elliptical paraboloid means that the penampang of paraboloid is yeah, elliptic. So in this equation, ellipse comes from this component. So based on this example, we can look at the characterization, the characteristic of this elliptic paraboloid. Z in the right will be the axis of the paraboloid, and the penampang of the paraboloids comes from this equation. So this characterization can be copied into other equation. For example, this equation means that this is the axis, x-axis, and the penampang is the ellipse in the YZ square YZ surface. So to draw or to picture this equation, we can do like this. This is x-axis, and this is y-axis, and this is z-axis. So the picture will be like here. This is the picture of this equation. What about the equation contain negative symbol, like this? How to draw this kind of equation? The negative means that the draw of this equation, have opposite direction with the positive symbol. For example, we know from the previous illustration, this equation can be drawn like this. So this equation can be drawn by using opposite direction. So the paraboloid will be like here, will be like this. So this is the paraboloids as the draw of this equation. Okay, I left the rest in the second or in the middle equation. You can draw it by yourself. So this is another example or another illustration for the elliptical paraboloid. Uh, Now we will talk about another quadric surface. It is called as ellipsoid. Is called as ellipsoid. Ellipsoid will can be draw or can be picture as uh, uh, like this, like rugby ball, uh, rugby shape, yeah, like this. And ABC in this equation, ABC in this equation, uh, is the length of reduce reduce along x-axis for A, y-axis for B, and z-axis for C. So this is A, and this is B, and this is BBC. Yeah. So the radius along x-axis uh, will be A, radius for y-axis will be B, and radius for the z-axis is C. And we can look at in this illustration A here, B, and C. And the last of the quadric surface is cone. Cone means that we have uh, two variables have power of two, and and also the third variable also have power of two, but this is have this x and y in the left side, and z is the right side. So the other other equation for cone can be right like this. The other equation might be z square divided by c square is equal to y square divided by b square. Might be like here, or maybe we have y square b square plus z square c square is equal to x square divided by a square, like this. Yeah, maybe we have some combination for cone. Cone uh, should be or must be have two shape. Yeah, uh, uh, goes to z positive z, and also goes to negative z. So there are two shape of cone. We cannot separate it. Yeah, we cannot separate it. This is default. Yeah. To draw cone, you should draw two shape, which have opposite direction. So to draw this kind of cone, this equation, we can look at that the y as the axis. This is the cone, and uh, This is the cons from this equation. For this equation, is left to you to draw it by using the example. Yeah, this is elliptical cone. Elliptical comes from the penampang of the cone. No, we will look at this exercise. There are 5 exercises, 1, 2, 3, 4, 5, and the exercise asks us to sketch and determine the type of the following surfaces. Uh, we must recognize, or we must know what is the name of the surface surfaces given in this exercise. For example, this is cylinder, or uh, specifically, this is parabolical paraboloid 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 cylinder. Yeah, this is uh, and we will draw it one by one. This kind of cylinder, this kind of surface is paraboloid. Paraboloid, yeah. This is paraboloid. Paraboloid. We will draw it later. In number 3, this is ellipsoid, which have the radius of x-axis, y-axis, and z-axis is the same. Are the same, yeah, are the same. And we know it as sphere, ball, yeah. Like here, the radius is 2. This is the surface. But in this case, there are statements we should draw and sketch the surface in the first equation. So we must uh, make a limitation. This is a cylinder and have special form. This is a plane, yeah, plane. And the last, this is a line. This is a line. Okay, after we know the classification or types of the surfaces given in this exercise, we will draw or we will sketch these surfaces one by one. We start with the first exercise. As we know before, cylinders, the type of cylinders uh, depend on the generating curves. Generating curves. There are paraboloid cylinder which have the generating curve is parabola. The generating curve is parabola. For example, y is equal to x square. The draw of this paraboloid as here. So we have the paraboloid like here. Yeah, this is the kind of paraboloid cylinder. So if we should draw this equation, we must draw x is uh, uh, equal to y square first. And as we know before, these cylinders means that we have parabola like here. This is x is equal to y square in the xy axis, and move uh, this parabola along z axis, along z axis. So this is the quadric surface. Okay, to make it clear, to make this the sketch of this equation, we move this parabola. Okay, there is a minus, so it means that we have opposite direction, not to the front, but uh, to the back, like here, like this, and then move or shift this surface to the front one unit. So we have this surface will be like here, like it. Yeah, uh, like here. And this is one x-axis, y-axis, z-axis. Yeah, maybe you can you confuse with my draw. I will help you to draw this surface by using software. I will use uh, wait a minute. I will open the software to give you a brief explanation about this surface. Yeah, yeah. This is the software calculus plot 3D, and we will draw the implicit surface, implicit surface, and we type the the equation. The equation x is equal to 1 minus y square. Yeah. So this is the sorry. Is there any? There is a chat in what happened.
Mister, can you copy the website link?
Okay, I will type in. But I have a problem with my mouse. Wait a minute.
Okay.
There is something wrong in my mouse. Uh, what happened? Hang. Okay. Oh yeah. Okay. I will. Uh, I will type it in the. Yeah. You can. You can open the software in the browser and uh, default for this software will be here. I will show you the default will be here. Uh, then you can erase this equation by click the x here and then choose the object you will be draw. We will draw a surface. So you can go to implicit surface and click it. You will have default equation, and then you can change the equation as you want to draw. For example, x is equal to y minus sorry 1 minus y square and click enter. So you will have the surface and click the surface in the left, in the right, and hold it, and then you can move the uh, the the surface like here, yeah. So you can see that the surface have parabola or parabolic, and uh, this parabolic move along z axis. So this is the surface of the first exercise. Yeah. Okay. Let's we continue to the second. Yeah. To the second exercise. Second exercise say that about paraboloid, yeah, as I told you before, paraboloid, and the paraboloid, uh, the standard paraboloid can be drawn like here. Z is equal to x square plus y square, and the standard paraboloid will be like here. This is a paraboloid, yeah, x, y, and z. Then there is a negative symbol or minus. Yeah. So we have that z is equal to minus x squared minus y squared. It means that we will have the paraboloid but in the opposite direction. So the paraboloid will be like here. This is the paraboloid for z is equal to x minus x square minus y square. And then move to up uh, 1 unit. So we will have z is equal to 1 minus x square minus y square. So uh, the the draw the 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 picture of this equation will be like here. Here, the top of the paraboloid is 1 in the z-axis, and so the paraboloid will goes to like here. Yeah. So this is the picture of second exercise. Okay, again, we will draw this equation by using calculus plot 3D to make you clear with the picture of this paraboloid. Okay, I will draw it by changing this equation. Z is equal to 1 minus x square minus y square. And click enter. I will have this kind of picture. Yeah. So you can look at that the top of the paraboloid is 1 in the z-axis. Z-axis. So this is the top, yeah, the top uh, of the surface. 1 in z-axis. What about if I erase 1? I will have this this paraboloid. And what about if I change minus symbol become a plus symbol? So we will have the paraboloid in the opposite direction. Okay, I hope this picture is uh, 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 clear for you, and you can know well about the surface. Let's we continue to the uh, to the third, yeah, to the third octane, to the third exercise. In this exercise, say that we must draw a sphere, but in first octane. So we will draw third exercise like here, x square plus y square plus z square is equal to 4. Okay, again, we use the calculus plot 3D to draw the picture. I will change the equation, become x square plus y square uh, plus z square. Z square is equal to 4. Okay, we have a sphere. Yeah, we have sphere, uh, and the radius is 2 because this is uh, square of radius. Okay, then uh, this the problem say that we should draw this pair only in the first octant, in the first octant. So we will have a limitation for the xy square, xy axis, sorry, xy axis. We change become 0 to 2, 0 to 2, and this is 0 to 2. So you look at that. This is the uh, the sphere, the sphere, the sphere bola, ya, bola in first octant, first octant. You know that the first octant means that x positive x, positive y, and positive z. Okay, this is the draw of the surface in the third exercise. Then this is for the fourth exercise. The equation of the surface is y is equal to x. Y is equal to x. Then uh, we change that y is equal to x. Y is equal to x. Okay, look at that. We have the plane. Yeah, we have the plane, and the plane is a cylinder. Yeah, cylinder. Where the generating curve is uh, uh, line of x is equal to y, and move the generating curve along z axis. So this is the equation. This is the uh, picture of the equation. Okay, let we continue to the last exercise. The last exercise say that we should sketch and determine or sketch this equation. Uh, this is uh, will be a line. Will be a line. So we draw it by using calculus plot 3D again. Okay, the line say that we have this equation. Uh, this is 1. This is y also 1, but z is any kind of number. So we have that uh, the the surface or the graph is a line. Yeah, the line. Yeah. Okay. We have uh, already talked about the exercise in the meeting 12. Let's go to the meeting 13. Yeah, meeting 13. Now we will talk about meeting 13. Meeting 13 will talk three parts. Part one is a partial derivative. Part two is a total differential, and part three is a chain rule. Let's begin with the first part, partial derivative. Suppose z is equal to uh, a function on two variable x and y. So z is a function of f of two variables x and y. Partial derivative z with respect to x, yeah, with respect to x, it means that y is a constant, is defined as zx, means that the partial derivative respect to x, or also fx like here, and or also we can write as do z do x. This is the symbol pronounced as do z do x. What is do z do x? Is the derivative with respect to x, and the other variable is uh, considered as constant. In this case, y is a constant. So the opposite side, on the other hand, we can also make partial derivative z with respect to y. Uh, it means that uh, x is considered as a constant. So we have zy or fy here. This is zy. This is fy, and it means that z uh, partial derivative of z with respect to y, or do z do y. This is the notation of partial derivative. Okay, I skip this interpretation because it's not too important for you to know it well. So I will jump into the next slide. This is the function f with have two variables x and y, and the formulas of this function is 4 minus x squared minus 2y squared. We should find partial derivative of f respect to x and also respect to y, then substitute the number or the value of x uh, with 1 and y with 1 also. Okay. First, we must know the derivative, the partial derivative. As we say before, partial derivative respect to x, it means that y is considered as constant. And we know that the derivative of constant is a 0. So this is 0 and this is also 0. So we have that minus 2x is the partial derivative of f respect to x. And respect to y, it means that 4 and minus x squared is considered as a constant. So we have that the partial derivative of f respect to y is minus 4y. Yeah. Because 4 and x squared is considered as constant. Yeah, after we have the formulas of partial derivative of f respect to x and also respect to y, and substitute the number of x and the number of y as 1 and 1. So in this case, the function of f depend on the function of fx depend on x. So substitute x by 1, we have the value of function, the value of partial derivative respect to x is minus 2. And also for partial derivative of f respect to y, and substitute the number of x and the number of y is 1 are 1 and 1. So we have that replace y by 1 and we have minus 4. So in partial derivative, we derivate we derivate or we do a, a differentiation as before, as we know in the calculus 1, or sorry, as we know in the previous material in previous meeting, but we must know what is the variable should be to derivate, and what the other as a constant. In this case, respect to x, it means that y is constant. In the other hand, respect to y, it means that x is constant. Okay, we practice or we do this example to make us know well about partial derivative. And I will help you to show the solution. Uh, uh, Partial derivative of f respect to x, it means that we will find fx x comma y, and the the derivative for x for 2x squared will be 4x, yeah, because 2 will go to the front, and the other without x will be considered as a constant, so the derivative respect to x will have, this is 0 0 plus 0, so 4x, yeah. And what about partial derivative respect to y? So we have that 2x squared and minus 4 will be 0. So we have that minus 3, yeah. Minus 3y is 3 minus 3. Uh, okay, this is the answer of this example. Okay, let's we continue to the another exercise of I will I must clear it. Okay. Then there are another order of partial derivative. In this slide, we have a second order partial derivative. So we if our function is uh, two variable x and y, so from z we'll have zx, zy, and from zx we will have to branch z xx or z xy, zxx or zxy, and also for here we have that z yy or z yx. And it means that if we have two variables, the second order partial, there are four formulas for second order partial derivative. Uh, and you can extend these formulas. For example, we have three the function of y based on three variables. So from y we will have we will have yx, y sorry, this is not y, w, sorry, w uh, is a function of x, y, z. It means that w will have three first order partial derivative, wx, wy, and wz. From here, we will have also three combination, wx, wxy, wxz, and so on. This is also three and also. So for the second order partial derivative of a function which have three variables, there are nine second order partial derivative. Please look at that uh, there are some notation for the partial derivative, not only one, but more than one. Yeah, we can say zx, we can say that dou z dou x, or we can say that fx. Okay, let's we continue to the example. As I told you before, if we find all second order partial derivative for this following function, so we must find four formulas. So from z we should find zx that what is that? uh, or it should be y not in the as a power, but y is multiplication of 2x square. Yeah, z is equal to x4 uh, plus 2x square y and minus y uh, uh, power of 3. So Zx is 4 x 3, and this is will be 4xy, and this is will be 0, yeah, because there is uh, uh, minus y power of 3 will be as will be considered as a constant, so the derivative of this component is 0. Okay, let's we continue. Zy, it means that we uh, uh, make a partial derivative respect to y. So this is will be 0, and this is will be 2x squared, and this is will be minus through minus 3 y squared. Okay, from the x, we can find zxx. It means that z x will be we will do the operation respect to x. So this is will be 12x squared plus this is will be constant for n for ny for y. On the other hand, on the other hand, the x y, it means that this formula will be derived respect to y. So we have that uh, what we have for uh, yeah, this is will be 0, this is will be 4x. Okay, then zy also have two branch, uh, zyx. It means that zy will be make a derivative respect to x. So we have that for x, and usually zxy is equal to z yx. Yeah. Okay, the last uh, the uh, the second order partial derivative, we derive zy respect to y again. So we have that this it will be 0, and this it will be minus 6 y. So this is the answer. Yeah, the answer the xx. So the xx is 12x squared plus 4y. The xy is equal to 4x. The yx is equal to 4x, and the yy is equal to minus 6y. Okay, student. This is all of second order partial derivative of this function. Let's we continue to the next slide, uh, we will talk about total differential. Total differential, it means that we find the value of differential of variable. uh, in this case, in this illustration, is total differential of y. Yeah, dy is equal to f dash dx. Why we can have this formulas? Because as we know that the f dash x is d dy dx. So multiplied f dash with the dx. So we have this formula. Uh, in this case, in this illustration, you can see that this is the initial point. Yeah, the initial point. This is uh, a x is a. X is equal to a, and then we uh, we change x become x plus delta x. So x1 is a and x2 is a plus delta x. And also for y, it means that y1 is equal to b maybe, and y2 will be b plus delta y. And this it can be find for this formula. And now, what about total differential uh, if we have function more than one? Because in this illustration, the function is a single variable. And now we will look at the total differential for the multivariable function. Okay, this is the total differential of function of two variables. Yeah, you can say that uh, the function have two variable here, x and y, and the total differential dz is equal to uh, total is equal to variable variables fx multiplied by dx and a partial derivative respect to y and respect to dy. So you must remember this this formula because we will use it frequently. Okay, total differential can be extended for the function more than two variables. We can uh, we can expand for more than two variables. So, for example, y is a function of three variables x, y, sorry, W is a function of three variables x, y, and z. So dw is equal to dou f dou x dx plus dou f dou y plus dy and plus dou f dou z multiplied by dz. So if the function is given, then we will find the total differential of uh, the variable. Okay, find the total variable of u which have formula x squared minus y squared. So as we know before that, the formula for this problem is du is equal to du dx dx plus dy d sorry do y do z do I repeat it again. Du is equal to do u do x dx plus do y uh, do y do uh, do make mistake again. Do u do y dy plus do u do z dz. This is the formula of total differential of u. There's no z. Sorry. Uh, so uh, we know that partial derivative of x of u respect to x is 2x, and partial derivative of u respect to y is minus 2y. Yeah. After you find the the partial derivative, and then we can have for the solution. This is 2x dx uh, plus minus 2 2y dy. Okay, I always okay. Yeah, minus ya, minus 2y dy. So this is the answer, 2x dx minus 2y dy. Okay, let's go to the uh, next example. In the next example, we have function z into variables, variable x and y, and uh, this example asks us to find the z, and if x change from 2 to 2.05 and y change from 2 to 3 to not yeah, oh sorry, 3 to 2.996, yeah, 96. Okay, uh, let's we try to solve number one. Number one, the formula said that dz is equal to zx dx plus zy dy, and we know that the function of z like this, so zx will be 2x plus 3y, and zy is equal to gy is equal to uh, 3x minus 2y. Yeah, and it means that to dz will be zx 2x plus 3y dx plus zy is 3x minus 2y dy. Okay, we already solved the first equation. And then we will solve a second problem. If x change from 2 to 2.05, so x1 is 2, x1 is 2, and x2 will be 2.05. So delta x is x2 minus x1 will be 2.05 minus 2. So we have that uh, uh, 0, 0, 5. Okay, let's do two y-axis. Y1 is equal to 3, Y2 is equal to 2.96. So delta Y is delta Y is what we call Y2 minus Y1. So 2.96 minus 3, it will be minus 0.04. And what about z variable? So z1 is x square plus x 3xy minus y square by substitute x and y with 2 and 3. So z1 is uh, 2 square 2 square plus 2 square plus 3xy 3 x will be 2 and y will be 3, and minus 3 square 3 square. So we have z1 is 4 minus plus plus 18, so 22 minus 9 become 13, yeah, 13. Okay, now we will count Z2. Z2 is x square will be 2.05 square plus 3 2.05 multiplied by y is minus 441, and the last we will have minus uh, what we call sorry, this is 3 multiplied by x and multiplied by y should be 2.96, yeah, and minus y square will be 2.996 square. Uh, please give me the answer for Z2 using calculator, and you can write in the chat box the solution. What is Z2? This is not, yeah, we have 2.96. Okay, please find the value of Z2. Okay, that is answer 13.6449. So we have 13 four sorry, uh, point 6449. 66449. Yeah. So we have delta z is uh, z2 minus z1, and then we have that 13.6449 minus 13. We will have that 0. Okay, I will change the color. Uh, 6.449. This is delta z, and we will compare the value of delta z by dz. Dz is, as we know from the first sample, we have 2 times 2, x is 2, plus 3 times y, 3 times 3, and multiplied by dx. Dx is same as delta x, and dy is equal to delta y. So we can replace dx by uh, 0.05 plus 3 times 2 minus 2 times 3 multiplied by the delta y. Delta y is minus 0.04. This is will be 0, and this is will be what we have uh, 13 multiplied by 0.05. How much? Uh, 13 multiplied by 0.05.
6.5. Wait, no.
No, 6, 6,
0.65.
6.5, yeah. This is the answer of the Z. So you can see that the value of delta Z is 0.6449, and dz is 0.65. This is actual value, and this is the approximation. Yeah, approximation. So this is real. Yeah, this is real, and this is approximation. Approximation. Uh, Approximation, and the advantage of dz is uh, easy to calculate. Yeah, easy to calculate. Compare to the delta z. Uh, Delta z is uh, uh, quite complex to calculate. So in the practical, in we always or we uh, replace delta z by dz, yeah, because uh, theoretically this value of this value of delta z and dz is close each other. Yeah, so we use dz to approximate delta z. We know that the value of dz is not the same with the delta z, but dz is easy to calculate compare than delta z. Okay, so this is the application of delta total differential. Okay, let's we use let's we know about chain rule. Chain rule. This is can be applied can be applied uh, for the function z which have two variables x and y, where x and y also uh, a function x and y also a function of another variable, another variable. So you can see that z uh, and have variable x and y, and each x and y also as a function for t of t, of t. And how to find the differential from z to t. So the question is, what is d z d t, dz dt, and uh, we have the formula to find the z dt, like here. We make a partial derivative of z respect to x and also z respect to y, and multiplied this partial derivative with the derivative of x respect to t and y respect to t. Yeah, this is how to find the uh, differential z respect to t. And in the second here, in the second, we have the situation z have that z is a function of two variable, which the each variable also a function of two other variables, u and v, and y is a variable of u and v also. And the question or the question is how to find the derivative of z respect to u and respect to v, respect to u and respect to v. And the answer is like here, yeah, like here, the partial derivative of z respect to u, and the partial derivative of z respect to v, and the uh, formula formulas to find the partial derivative is like here. So we have the partial derivative of x of z respect to x and z respect to y, and multiplied by partial derivative of x respect to u and y respect to u. So the variable is have the same variable, and also for partial derivative of z respect to v. If you feel hard to memorize it, or hard uh, to know well these formulas, we can use a diagram, a branch diagram for chain rule. This is the situation where z is a function in two variables x and y, where x and y is a function of two other variables s and t, and we make the diagram z in the top, and z have to z is a function of two variables, and we make the variables x and y here. And if we take the differentiation of z respect to x, it means that this is partial derivative of z respect to x, and also z respect to y, uh, like here. For x, uh, x is a function of two other variable s and t. Also, y is a function of variables s and t. It means that the derivative of x respect to s is partial derivative, and also x respect to t is partial derivative, like here. Yeah. Also for y, we have partial derivative respect to s and respect to t, like here. So uh, to to find the partial derivative of z respect to s, we have two uh, two two ways. Yeah, two ways to have a derivative of z respect to s. This is the first way, and this is the second way. Second way, and then uh, uh, add this two-way in this formula. So this is will be multiplied by this one, and also this is will be multiplied by this one, and then uh, 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 add them into this formula. So uh, dou z dou x multiplied by dou x dou s plus dou z dou y is here multiplied by dou y dou t dou s, sorry, dou s dou y dou. Oh, sorry, this is not uh, which is the will be here. Yeah. And also, if you want to find the partial derivative of z respect to t, you also have two ways. The first way is z to x and x to t, and the other is z to y to t. So we have that this is will be the formula of z respect to t. So dou z dou x dou z dou x multiplied by dou x dou t, and plus dou z dou y dou t. So this is the formula to find the partial derivative z respect to t, and this is z respect to s. Yeah, we can extend the formula of chain rule. For example, maybe z have is a function of four variable, and each variable for variable depend on two variable u and v. So this is the branch diagram of the partial of the chain rule. The top is w, yeah. Sorry, this is should be w, man. W, W, W have four depend on four variables x, y, z, and t here, and each of x, y, z, and t is a function of u and v, u and v. Yeah. So we can find the formula for dou w dou u or you can also find the formula of dou W or dou V. Yeah. So by using in the previous example, by using previous example as a guide, a guidance. Okay, let's we apply to the uh, example. Z in this example Z, sorry. Okay, Z is a function of x and y, and each of x and y is a function of u and v. So we will find the dou z, dou u, and dou z, dou v. We should write the formula first. Dou z, dou u is dou z, dou x multiplied by dou x, dou u plus dou z, dou y, dou u. And dou z, dou v is equal to dou z, dou x multiplied by dou x, dou v. And dou z, dou y, dou v. This is the uh, the formula. So dou z, dou x or zx is 3x square, and zy, yeah, zy or this is dou z, dou x, and this is dou z, dou y, yeah. Dou z, dou y is 3 y square. And for x, dou x, dou u is equal to 3, dou x, dou v is equal to minus 2. On the other hand, dou y, dou u is equal to 2, dou y, dou v is equal to 1. Okay, let's apply all this information to find dou z, dou u. It means that dou z, dou x here 3x square multiplied by dou x, dou u multiplied by 3 plus dou z, dou y 3y square multiplied by dou y, dou u. Dou y, dou u is 2. So we will have the equation is 9x square plus 6y square. And then dou z, dou v is same 3x square multiplied by dou x, dou v. Dou x, dou v is minus 2 plus 3y square. Yeah, this is 3y square multiplied by dou y, dou v. Dou y, dou v 1. So this equation of uh, this example, this answer of this example is minus 6x square plus 3y square. Okay, this is the answer of the the example. This is the answer of the example. Okay, let's jump to derivative of implicit function. Sometimes our function uh, uh, is implicit function, not explicit function. Implicit function means that x and y in one side and cannot be separate cannot be separated uh, into two types. So we have how to find the partial derivative of implicit function. Yeah. Uh, so if we don't know how to make this function become explicit function, so derivative of y respect to y is equal to minus ratio of derivative partial derivative of x respect to x divided by partial derivative of f respect to y. Okay, let's we apply these formulas. Uh, Also, a derivative of x respect to y can be found like this. Yeah. Okay. Okay. Uh, this is the f x and y, and we want to find dy dx. The formula said that this is minus dou f dou x divided by dou v dou y. Okay. Is it true? Oh, yeah. So this is a function f, x and y, and the dy divided by dx is minus dou f dou x and dou f dou y. And then we make or we find the partial derivative first. Dou f dou x is we make a derivative with respect to x. So y cosine x plus 2x square root of y. And dou f dou y is equal to, this is will be sine x, yeah, sine x, because y the derivative of y is 1, and plus this is x square, and the derivative of square root of y is uh, what a half y power of minus 1. Oh, sorry, not minus 1. Yeah? Uh, 12, 12 y is minus a half. So, so dy dx is minus y cosine x plus 2x square root of y divided by uh, sine x plus a half, minus ya, minus a half, oh not minus, plus ya, plus a half x square y minus a half. So this is the example, the answer of the example. Okay, let's go to the last slide. Last slide. This slide say that uh, the extension of partial derivative of implicit function. In the in the first, in the previous slide, the situation is f contains two variables where y is function of x. So in this slide, uh, this concept this concept is extended. So if we have three variables x, y, and z is equal to 0, and z is a function of x and y. So two three variables, and this is two variables. So the formula to find dou z dou x is minus dou v dou x divided by dou v dou z. So if in the other hand, dou z dou y will be minus dou f dou y divided by dou f dou z. Okay, sorry, I missed something. Okay, this is the partial derivative of three variables, function implicit function of three variables, and this is the formulas to find partial derivative of z respect to x and partial derivative z respect to y, because z is a function of x and y. And as I told you before, you can extend for the maybe f contain four variable, ya, w, x, y, and z is equal to 0, where w is function of x, y, and z. Okay, so uh, uh, we so we have three formulas: do w do x, do w do y, and do w do z. So this is the extension of this problem, and the formulas is similar to the another formula. Okay, this is the example and the exercise. Yeah, the last. Yeah, this is example and the last. The example. Uh, in this case, we have that there are three variables. So this is a function of three variables x, y, and z is equal to 0, and Z is a function of x and y, like here. So we can find dou z dou x. The formulas of dou z dou x is minus dou f dou x divided by dou f dou z, dou f dou z, and dou z dou y should be minus dou f dou y divided by dou z dou f dou z, and it means that you should find fx. uh, Fx is 3x squared a e uh, has a power y plus z, and minus this is sine become cosine, minus y cosine x minus z, and fg is x cube uh, e power of y plus z, then uh, uh, minus y cosine x minus z minus 1. So we have that x cube e power of y plus z minus y plus y cosine x minus z. Okay, the last we should find the partial derivative of f respect to y. So we have x cube e y plus z and minus sine x minus z. Okay, so dou x is minus minus here minus uh, minus 3x square e power of y plus z minus y cosine x minus z. Then divide by dou z dou f dou f dou f dou z. Dou f dou z, it means that x cube e y plus z plus y cosine x minus z. Okay, the last uh, uh, the the last question is dou z dou y is equal to minus. Don't forget the minus. Minus dou f dou y. Dou f dou y is uh, x cube e y plus z, and minus sine x minus z divided by x cube y e y plus z minus y cosine x minus z. Yeah, this is the answer of this example. Okay, the last slide contains exercises 1, 2, and 3. Uh, I will help you with the formulas for this exercise, and the rest should be fixed by yourself. Uh, do f do x, it means that we use partial derivative of f respect to x. Yeah, y is can be considered as a constant. So this is 2x, 2x minus if we take a derivative of x will be 1 and minus 5y. And do f do y, on the other hand, we take a derivative of y to y, and this is minus 5x. And also for B, 1b so also do f do x and do f do y. This is using implicit function, derivative, partial derivative of implicit function. Also this one, implicit, implicit function. Yeah, it means that uh, x square plus y square plus z square minus 4 is equal to 0. This is the function of three variables x, y, and z, where z is a function of x and y. So we can find the z dot x, or we can also find the z dot y. But in this exercise, uh, only for the z dot x. And as we know before, the z dot x is the x is equal. The z dot x is equal to minus the f the x divided by the f the y. Okay, please find by yourself dou v dou x, dou v dou x divided by dou v dou z, not dou y, dou v dou z. Okay, for number 3, as we know before, we should find 4, yeah, 4 second partial derivatives z or f(x), fxy, fyx, and fyy. Yeah. Okay. I think enough today. My time is 9 past 32, and I think is enough today. The registration of absentee is not available today. I will open the registration of absentee in the other day, and I will give you the information what day to registration for this class, for this today class. Okay, thank you very much, students. Thank you very much for your nice attention today. Even holiday, you join the class. Thank you for your what we call sacrifice. Okay. Uh, 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 Good morning. It's still in the morning. Good morning and bye bye. See you in the next week.
Thank you, Mister.
Thank
Yes,
you,
sir.
sir. See you next week.